Swifters, it's Prof G, and it's time to ace that API access as if you were Ash Ketchum or Misty. To do this, we're going to use URLSession and Swift's built-in JSON parsing features to call the Pokemon API and catch the first page of creatures. Let's learn big! So if you followed the earlier lesson, you've got a basic list of placeholder data Pokemon, but we don't want the creatures that we entered into our app. We want to get the data over the internet from the Pokemon database. So to do this, let's create a view model that we can use to handle accessing the API, getting the data from the web, and parsing, meaning extracting and filtering, just that data that we want so that we can put it in our variables and display it in our Pokemon list. So I'll create the new view model file just below the Catch 'em All app file in the project navigator, and to do this, I'm going to right-click on the Catch 'em All app file, then select New File, Swift File, not SwiftUI View, and I'll name this Creatures View Model. And if you completed the prior lessons on creating the to-do list app, that's where we learned about view models. So remember that a view model is where we typically store programming logic and data handling logic for our app. So this is where we want to put in the code for API access and parsing out the data that we want. So we're going to create a class in here by stating class creatures view model colon, and this is going to be an observable object because we want any objects created from this class to be observed by our app, and we want any properties that we create in this class that are marked with the published property wrapper to trigger SwiftUI's user interface to redraw if those properties are changed. But before we add any more code to this class, I want to show you the JSON and talk through how we're going to make our API call. So we're going to use Swift to parse or filter or extract just the JSON data that we need. This here shows the top part of the JSON that you'd see in a browser if you access the Poke API at the URL pokeapi.co/api/v2/Pokemon. Now, JSON is organized in key value pairs, with the keys and values separated by colons. This is similar to dictionary types if you know what that is, but if not, the key is the name of the data, while the value is the data itself. Now, for starters, we're only going to extract a bit of the data just to confirm our API call and the code that we're writing to extract the data is working. So we're going to get data from the count key, this number here, and the next key, which is this string here that contains a URL that we'll use to get the next page of Pokemon in a future lesson. Now we'll eventually get the results of the array of Pokemon down here, but we'll start out with just these two values to make sure that things are working. Accessing this Pokemon data down here is just a smidge more complex, and when learning, I think it's always good to work in stages, one smaller step at a time. Now we're going to use a SwiftUI object called URLSession, which is going to get the JSON for us, but once we have that JSON, we're going to need to parse out the data into our own variables. So we're going to need to create a structure that matches the JSON that we want. This is going to, in a sense, create a sort of data container that we can pour the JSON into. And Swift makes this super easy. As long as we create a structure that conforms to Codable, remember we learned about that in our to-do list app, and has properties that match the key names, the names have to match exactly, same spelling and case, and each property or variable holds data of the same type as the JSON, so this is an int and this is a string, then Swift will let us pour this JSON into the custom data structures, getting just the data that we want. And we'll use a JSON decoder for that, and remember we first used a JSON decoder in our to-do list app. Cool! Now remember the key names need to match the struct's properties, these variables. Now I could have called the struct itself, the returned up here, any valid struct name, but I like capital R returned, so I often use that in the apps that I create. So this is how we create a container to hold the JSON, but how do we actually get that JSON from over the internet? Well, these are the steps. And we'll put these steps in a function that's going to be pretty reusable. Now, this is what we're going to do. We're going to write a function called getData. We could call this function anything, but I like the name getData. And we need to do something that we've not done before. We need to mark the function with the async keyword just before its opening curly. Now, this means that the function is an asynchronous function. It'll run, and the rest of the code doesn't have to wait around for the results to be returned. Your app will still function so it won't look like it's frozen. Now, this is important when accessing the internet because sometimes accessing data over the internet is noticeably slow, and we don't want the app to freeze otherwise while we're waiting for the results to come back. So asynchronous functions are marked with the async keyword, and they don't cause the rest of the app to freeze or wait. The app continues to function, but when the results come back, the app will perform the rest of the code in this function. Next, we need to create a URL that we can use to access our data. Now, I like to use the value named URL string, which is a string, but what's important here is we need to convert this to a special URL type that Apple needs. Swift can't make an API call with a string. So we use the guard statement to try to convert the string to a URL. If it doesn't work, we print out an error and return, but if this works, we've got this URL set up in a constant called URL. Now this line up here prints the URL that I'm going to be using in this API call with a spider web in front of it. This can be super useful when debugging JSON in your app, because if you run into a problem and you want to find out the last URL that you used when making an API call, you could just look in the console for the last web emoji that prints out, and you can copy the URL that comes after that, then paste it in the browser, take a look at the results you were supposed to get back, and compare that with your code. Then we'll call URLSession, passing in the URL that we just created. Now URLSession is a special object that handles getting JSON data over the internet. It returns data in the JSON format, and it returns a response, which is usually a status code that reports if the call worked or not, and it'll also throw an error if we have a problem with the URL session. Now in this case, it'll either work and we'll get data, or we'll throw an error, so I'm going to ignore the response value in here. That's why I have an underscore. This also looks a little strange here because you can see that we're getting two values back inside of parentheses here. Swift calls this a tuple. Tuples are pretty common in programming languages. It's a result that can actually contain multiple parts in here. We've got data and response, even though we're only using data. Now, another thing to know about URLSession is to get data like this, it can throw an error, so we put the try keyword out front, and we're inside a do catch clause, so we're covered for that. But this function also runs asynchronously. This is the reason that we needed to put async up here in the function declaration. So Swift requires us to put another keyword, await, in front of URLSession, just after try. Now, if we forgot to do this, and we'll deliberately forget to do this when we're writing our code, Xcode is going to demand that we add this in, it'll offer to fix it for us, and I'm going to both forget the await keyword and the async keyword in the function so you can see how that'll work. Again, we got a lot going on here, but we'll see it in action in just a bit. Now, once we have the data, we decode it using a JSON decoder, which again, we saw in the to-do list app. Now remember that returned is the name of the struct that matches the JSON key value pairs we want to access. We talked about creating that in the previous slide. So we need to refer to it here with the .self term after it. And the from value here is data that we got from our URL session that contains the JSON. So this is going to decode the JSON. It's inside of a guard statement, so we're going to print an error if it doesn't work. Otherwise, we're going to have decoded the JSON into the variables in a return struct, and we'll have that data inside of a constant called lowercase returned. Now, if this works out, all I'm going to do is print out the count and the next properties of that returned constant, but if this fails, we'll catch and print out an error. Now again, this code looks kind of gnarly for the beginner, but it's very reusable. So if you have a structure called returned with a capital R, and you pass in the URL for your API as a string called URL string, for basic API access, the only thing that's different is this line here that prints out the two values that are specific to the Pokemon API. Cut out that line, and you've got a reusable starter chunk of code that you can customize as you need it. So let's code this up and see if we can get some data. So now let's enter the code we just looked at. We'll add our getData method with func, getData, open and close parens, open and close curlies. Now I'm not going to add something that we need in here, our async keyword just before the open curly. I want to show you the errors that you'll get if you forget this, so I'm deliberately leaving it out right now. Now, our first step is to get the URL. And as I mentioned, I like to pass this in using a variable called URL string. And even before I convert the string to a URL type, I like to print out the URL that we're accessing. Again, this can be really useful. If you get an error when you're running your getData method, you can just look in the console at the last URL it prints out, copy that, paste it in the browser, and then compare that with what you were expecting to work with in your code. So to do this, I'm going to say print, and in between double quotes, web emoji, since we're accessing data over the web, followed by we are accessing the URL, string interp, and what do we put in the string interp? Well, I usually standardize on using a variable called URL string that holds the string that we will eventually convert to a URL. So up here, I'm going to add a property var URL string equals double quotes, and then to make sure that I have the exact URL, I'm going to head over to the browser, and I'm going to copy the URL that shows the first page of JSON that I want to access. Now this is the same URL that we had showed earlier in this lesson. It's pokeapi.co/api/v2/Pokemon/ all lowercase. And then I'm going to return to Xcode. I'm going to paste it in between quotes, add URL string to the string interp in my print statement, and that's it. Next, Apple needs to convert the URL string to a URL type. Now, this might fail, so in case it returns nil, we'll use a guard let statement to guard against the nil with guard let URL equals capital URL, open parens, select the option with string, pass in URL string, else, open and close curlies, return, and above the return, we'll print out that an error occurred just so that we can see this in the console if we run into problems when we're building our app, so we will print error, could not create a URL from string interp and pass in URL string. And I always like to put an angry emoji before my error statements so that they're easy to find in the console. Now, once we have the URL, we're going to make our call to URLSession's shared data method. Now, this method could throw an error, so we're going to do this inside of a do catch clause like this. And when we try to get data using URL request, it can give us back a tuple. Now, some folks call that tuple. I say both, don't at me. And that has a data value and a URL result. So we'll start this by saying let, and in between parens, the two values we'll get back. We only care about the data, so I'm going to say lowercase data, which is actually of type capital D data. Now I'll start out by saying comma response in here, but Xcode is actually going to complain at us later on when we're done with writing this function because we're never going to use response. We'll eventually replace this with an underscore. But I want to show you, if you ever write a more advanced API access in the future where you really want to take a look at this response, you could just call it whatever you want in here. Response is a good name. Then we set this tuple equal to try, and we need the keyword await in here, but I'm going to deliberately leave this off so that you can see what kind of error occurs. And then we'll add URLSession.shared, then enter .data. And I want you to highlight the option data from, but you see that it's grayed out. I'm going to continue to type .data with open parens and highlighting the option with from in here. And we see a red error ball down below. Now, the reason this shows up is because I specifically didn't include the await keyword before URL session, and I didn't include the async keyword in the getData function definition. See what else code completion is telling us? It says this function is async and throws. Now we've got our do try catch set up. As far as throws goes, we got that covered. But since this is async and we left out the two keywords that we need, await before URL session and async in the function definition, Xcode is telling us that this isn't even a method that we can properly use right now. I'm going to select this anyway though, and it wants a URL, so I'll pass in the lowercase URL, the value that we created above. And because we didn't use async and await when writing code, we're getting a couple of errors in here. It says we're calling an async call in a function that doesn't support concurrency. So I could fix this and Xcode will add the async keyword after getData, but another error is that we needed to add await after try, and I could fix this as well, but even better, I'm going to undo those fixes, and what you really want to do is to remember right from the start that URL session requires try followed by the keyword await in front of it in that order, and since this awaiting method is inside of a function, this function needs to have async before the open curly. Now, before we can do anything else with the data that we got back, let's print the error message in the catch clause. I'm just going to copy the error message from above, paste it into the catch, and I'm going to fix my misspelling of could, and I'll change the catch error to read could not get data from URL string. And now we have data back from URL session. We want to decode this data value, which contains JSON, into our own data structures. But we haven't created our data structures yet. Well, let's do that now. And as we pointed out earlier, since we want our count and next values, and those are at the very base level, we need to create a data structure that matches what we see on the web page so that the JSON can in effect be poured or decoded directly into matching data containers that we create. So we need a count value that is an int and a next value that's a string, although I'll eventually point out that this string here actually needs to be an optional string. And not to get too far ahead of ourselves, but you see how previous is null here? Well, if I clicked on this, it would go to the previous page of Pokemon. But since there's no previous page, since this is the first page, that's why it says null. Null is JSON speak for nil in Swift. Well, eventually we're going to get page after page of Pokemon, and when we get to the very last page of Pokemon, this next value is going to be null too. Now, I'm not going to create our next value as an optional string yet. I want us to see the error in a later lesson. I think that's going to be useful because not realizing that your data can contain a nil or null value is a very common thing to experience when decoding JSON in Swift. So if you see that now, hopefully if you encounter this later on in your career, and I'm sure you will, you'll know what to do. So to back out a little bit, let's go ahead and create this struct. I'm going to say private struct, name this capital R returned. Very important, since we're using this to decode JSON, you want to say :Codable, conform to the Codable protocol, open and close parens. Then inside the struct, we want to create a data container that's identical to the key value pairs that we want to retrieve. So inside here, I'll say var count:"int and var next:"string with a comment that says to do. We want to change this to an optional, but I'll demo why later. And so now that we've got a container that matches our JSON, why don't we pour some JSON into it? So our JSON data is inside our value named data, which we got back from URLSession in the tuple up here. And I say pour, but what we really need to do is decode this JSON into our return data structure. And this will be very similar to how we used the JSON decoder in the to-do list app, where we read in data that was saved to our device. It's just that in this app, instead of the data coming from JSON that was saved to our device, it's instead coming from JSON that was delivered over the internet. So in the do clause here, after we get the data and response tuple, we'll say guard let lowercase returned, and I could call this anything in here, but a lowercase version of the uppercase struct name is the convention that I want to keep, and we're about to decode the capital R return struct, and we'll set this equal to try question mark, and remember the try question mark here just means that if we throw an error, we'll just return nil, we'll ignore the error. Then we say JSON decoder, open and close paren, so that creates the decoder in here, make sure it's a DE coder, and we'll say dot calling decode, and this wants the type and the data that we're decoding from. So press return to accept this, and we pass in the type the same way we did in to-do list. So the name of our type, in our case here, this is capital R returned, followed by .self. See, that's this guy up here. And then for the value, we just put in lowercase data, which again is this value that we got from the tuple. As mentioned, we didn't need the response value in here. Many developers will ignore this, and for our simple Pokemon app, we're going to ignore it too. So I'm just going to replace the response value in the tuple in here with an underscore. That's going to silence the warning that Xcode keeps giving me that I have this unused response value. And now I've got to end guard with an else, open and close curlies, put return in between, and I'll copy my error statement from down here, and I'm going to paste it above that return statement, and I'm going to change this to read JSON error could not decode returned JSON data, and then just below this, just to confirm that our JSON is decoding properly, I'm going to print out JSON returned, count string interp, next string interp, and in the first string interp, I'm going to put in returned.count, and in the second one, I'll put in returned.next. And I think this is very cool, so I'm going to put a cool emoji in front of this text. That'll also help so that I can find it easier in the console. And below this, I'll put a to-do statement that says decode JSON into classes properties, but we need to add these, and we'll do this after we get our basic API call working. And this error in the catch statement, I'll just say error could not use URL at URL string to get the data and response. I'm actually doing this to keep the code consistent with an edit that I had to come back and fix. So I just want to make sure that the code in both parts of the videos looks identical. And I'll modify the comment above the URL conversion that says convert URL string to a special URL type. So now we've created our view model and our getData function that should make the API call and parse JSON data. So let's call this. And right now, we won't do anything with the JSON that we get back. We just want to make sure that the results print to the console properly. Then once we verify this works, we can go back and modify the view model so that we can get more data, including that initial array of 20 Pokemon creatures. So to call getData, we've got some work to do in our creatures list view. So let's head over to that file, and to use our creatures view class model, we'll create an object from that class. So right under the creatures array, which we'll eventually replace, I'll start writing var creatures vm equals creatures view model open and close parens. But this isn't enough. Remember, creatures view model is a class that conforms to observable object. In the to-do list app, we learned that we create our first instance of an observable object by prefacing this with @stateObject. So I'm going to add @stateObject just before the var statement where I create my creatures object. Now, we could have done this in the app file and created an environment object like we did in our to-do list, but here's the thing. An environment object makes sense if you're passing an object around between views, especially if you're updating that object. And we needed that in our to-do list because we were updating data on two separate views. But here, we're only going to be showing this list of Pokemon on this first view, the creatures list view. So we don't even need an environment object here. We can just use the state object to create our observable object and call it a day. So to sum it up, if you need to pass an object around between views, especially if you need the ability to update it across views, then use an environment object, and the to-do list showed us how to do that. Now remember, when you use an environment object, you still have to create the first instance using @stateObject. But if your object is only needed on a single view, you can just create the state object and that's all you need. Now under the hood, the view where the state object is created is considered the owner of the object. Now in to-do, we created our state object in the app file and we passed it around as an environment object since it could be updated in both the to-do list and our detail view screens. But here, we don't have that complexity. The list of Pokemon is never getting updated beyond this first screen, so creating that object with the @StateObject property wrapper here and not going through the extra steps of the environment object is perfectly fine. Now how do we call getData on the object? We're going to use a special modifier called task, which acts sort of like onAppear, and it'll let us call asynchronous functions just before a view appears. Task is only for async functions, so just below the closing curly for the navigation stack, I'm going to write .task, open and close curlies, and inside I want to call the getData function using the creatures VM object we just created. So I'm going to enter creatures.getData in between the curlies, and before I press return to accept this, notice getData is marked by code completion as async, so I can use this inside my task modifier. If I tried to put this directly inside of an onAppear, I'd get an error. Again, task is for async functions. But if we press return to accept this, we're forgetting one more thing, but Xcode will offer to fix this. We need the await keyword before the async function call, so click fix. Await is added out front, just like it was added in front of the URL session in our getData function. And with this, we can press the play button to build and run in the simulator, and we want to use the simulator here because we want to see output printed to the console. Hammer time, no errors. And when we look at the console, we see the cool emoji. It says JSON returned. We didn't get any of our errors, so things are working fine. In my case, I see we've got 1,154 Pokemon. There is a chance you may see a larger number in here. Remember, the Pokemon Company is constantly introducing new Pokemon. And we also see that we've got a URL in our next field. Congratulations, Swifter. You just accessed an API and decoded JSON. Now, let's up our game and get that first page of 20 Pokemon so that we can display it in our list. So let's head back to the creatures view model and we'll modify this class so that we can get more of the JSON data. But even before we do that, I'm going to add an @published property wrapper in front of URL string, since I'll eventually want to have access to this value as it changes. Now I'm also going to create a published property hold count with @published var count equals 0. And now down here in the do catch clause of my getData function, I'm going to highlight and delete the line where I printed out the cool emoji, and instead I'm going to load up the published values that I just created like this: self.count equals return.count and self.urlstring equals return.next. And I can get rid of the to-do comment since I'm now decoding JSON into class properties. So back to the top of the class, we need to make some additional modifications so that we can get an array of Pokemon. Now, if we look back at the JSON that we want to access, we see that all the Pokemon are inside the results key. Now, after the colon, it's not a value like string or number. Instead, we see an open square bracket that indicates that this is an array. And the curlies separated by commas show each element in the array. And each element between the curlies shows a name string key value pair and a URL string key value pair. And this continues down. See, name URL, name URL, name URL. That's because this is an array. So we want this. So we need to make sure that our first struct that we get, which is, remember, our return struct, which already has properties for count and next, will also have a property for results, spelled the same way in lowercase letters, just like this key. And this results should be an array of a new struct that we need to create that has a name property and a URL property inside of it. Now, it doesn't matter what we call the struct, but I figured we'd call it result singular, since we're getting an array in this key here, which is results plural. So let's head to our class and create this. So I'll start out with private, and you'll see in a bit that I actually shouldn't use private at this level, since I'll need to refer to this struct in other parts of my code. Struct, capital R result, colon codable, very important. If it's not codable, then we can't use it for decoding JSON, so make sure codable is in here for anything that you use in decoding. Open and close curlies, then inside the curlies, var name colon string, var URL colon string. This URL, by the way, is going to be for accessing detail on each Pokemon. We'll use that in a future lesson. And now we need to modify our return struct above. We'll add a var results. Now remember, it's got to be spelled exactly the same way, the same cases we see in our JSON in the browser, colon, and in between square brackets, result capital R, since this is an array of the new result struct that we just created, So now below, I want to create a published variable to hold an array of this new result type. This is going to hold the Pokemon that we get from the JSON and parse out so that we can display it in our list. So I'm going to say at published var, I'll call this creatures array, and I'll set this to an empty result array with colon, bracket, capital R result, close bracket, equals, empty square brackets, and I'm getting an error in here. And this is because I declared the result struct as a private struct. So since I use this struct in a published variable, this needs to be visible outside the class. So I need to remove private in here, which restricts this so it's only visible inside the class. Once I get rid of private from in front of result here, the error goes away. Then, down where I decode my JSON, I'm going to add a new variable here as part of the decoding. I'll say self.creaturesArray, and notice code completion says creaturesArray is of type an array of result structs, equals returned.results, and look at this. The results property of return is also an array of result type. Since they're both the same type, we can set these guys equal to each other. That's all we need to do to get those Pokemon. So now let's head back over to the creatures list view and use the changes we just made. Now I no longer need this creature array that had the placeholder data, so I'm going to highlight and delete this because the data that we want now is going to be inside of creatures VM. Oh, and inside of the list here might look a little bit different from your code. At the end of the lesson where we set up the user interface, I'd already deleted the for each statement. I didn't make that change in this file here, but no big deal. We're going to recreate the list anyway, so I'm just going to highlight the two curlies that make up the list and delete that, and backspace over the word list and start to retype list. I'm going to select an option with data ID and row content. Now the data is going to be creatures VM.creatures array. That's our array that will hold Pokemon. It's going to have the name and URL inside, although we won't use the URL until a future lesson. Then I'll tab over to ID, and for now we'll just enter \self like we've been doing, and I'll press return on row content. This gives me the trailing closure format, the value before the in. Again, there's a bunch of different options that you have in here, so the text that you see in here might be a little bit different, but just before the in keyword, this is where you want to enter the name of the constant that we're going to use as we iterate through our array. So we'll just call this creature since we're going through the creatures array. Then we'll tab over to code, and here we'll enter a text view passing in creature.name. And here we've got one more error that we need to address. Again, very common when working with SwiftUI. This says we're not conforming to something called hashable. For now, all we need to know is that conformance to hashable is necessary for an array that we want to iterate over, like we're doing in this list. But all we need to do to conform to that is to head back to creatures view model, and in our results struct right after we conform to Codable, we'll add comma, hashable, error fixed. We'll head back to Creatures List View and look it over here at the live preview. Jumpin' Jigglypuffs, Professor Oak. We've got a whole list of Pokemon in here. We didn't type those in. They came from the API call JSON successfully parsed. Why don't we make these names a little bit bigger by adding a font modifier of title 2 after the text view, and I can actually clean up this trailing closure, making it a little bit neater by deleting the closing paren after the closing curly, then highlighting and deleting the comma row content colon and replacing that with the closing parens. Again, yours might be different depending on the format of the list option that you selected, but if you want to clean things up like I did, feel free to. I think this is the syntax that you're going to see most developers using. So this looks dynamite. API call done. JSON parsing mastered. Another ultra awesome skill in your tool belt, Swifter. But we're going to learn a lot more as we continue to build out this app. So stay tuned for the next lesson and continue to hack.